Good morning, everyone. It's Mr. Murphy again, and I'm here to talk about Archimedes' principle, or the basics of Archimedes, and that is volume. And right now, you should have already looked at the volume notes and the PowerPoint and taken that information down. So you should have a good idea about this demonstration that I'm going to show you today. So there are a couple different things I want to talk about. I have a couple different objects here. I have a spherical ball, and I have a cube. And so there's a couple different ways that you can find volume. So I'm going to go over that first. The first way is if you have a regular shaped object like the square or cube I have here, I can take a ruler using centimeters, and I can measure, right, the length. This is kind of hard to show. I can measure the length. Right, then I can measure the width, and then I can measure the height. So with those three measurements, length times width times height, I can calculate volume. So if I look at this cube here, I have 2.5 centimeters, and since it's a cube, it probably should be the same, but not always, so I'm going to check it. 2.5 centimeters, and then 2.5 centimeters. So that'd be 2.5 times 2.5 times 2.5, and I'm going to get my calculator out for that calculation, and when I do that, I get 2.5 times 2.5 times 2.5, and I get 15.625. And I'm going to round that to the nearest tenth, right? So when I round that to the nearest tenth, it comes out to 15.6. So I have 15.6. Now I'm going to write that down quick so I remember it. 15.6. Remember, that's data, so you want to keep track of it. So I'm writing it down on my notebook on the side here. And you notice I have this jar, or this basically two sets of beakers, or double beaker here, and we're going to talk about that in a few minutes. So if I'm looking at the square, right, that I have here, right, we can talk about volume as in volume taking up space. So in other words, this square takes up, or cube, takes up space. And it takes up the amount of space, right, that I measured, which is 15.6 cubic centimeters, right? That's the space it takes up. So later on, we're going to do something, demonstrate with this, and we're going to see how close we are to the amount that we have. So we can find those equal. Now, before I start with this, I'm going to slide this out of the way for a second, very carefully, not spill any. And I'm going to put my graduated cylinder here. Notice the graduated cylinder, right? This measures in volume of liquid, so I have 10, 20, 30, 40, and 50 is up above the yellow marker here. So if I needed to mark something, I could slide this up and down, find the meniscus, right, which is the bottom of the curve, right? Find the meniscus, and I can measure from there. So I'm going to slide this up to the top for right now, and because I'm not going to use that quite yet. And what I want to do is I have another beaker here. And if you look at this beaker, right, you can see there are also measurements on this beaker here. And if you look, you can see at the bottom I have 50, then I have 100, then I have 150, so on and so forth. And this is a 400 milliliter beaker, measures accurately up to 300 milliliters. So pretty accurate, but not perfect. And remember, I have this one over here that has smaller, right, smaller increments. So if I go, I have 10, 20, so in between I have 10 plus 5, which would be 15. Or I can go even smaller than that here, and I can show you, right, each individual milliliter as I go up. So let me talk a little bit about this. I know there's some light in the background, so I'm going to do the best I can with this. So I'm going to talk about, I have almost 50 milliliters supposedly in the thing. So if you look at this, right, this says 50 at the top. So one of the things about volume is it takes the shape of the container it's in. So you can see in this beaker, right, it has a, I put a coloring dye in here so you can see it better. And you can see in this beaker, right, it's in the bottom of the beaker, and it's not filling up very much of this. So if I take and I put this in here, remember I have approximately 50 milliliters. And I fill that to the top. Right, you know, I'm empty now, my beaker's empty, right? And I put that in there. If you notice, right, it doesn't quite, I'm going to raise my camera a little bit here, right? It doesn't quite reach the 50 mark. Here's my 50 mark. So it comes up to, if you read the meniscus correctly, right, it comes up to 40, and then I have these smaller ones in between, so it'll be 41, 42, 43, the bigger line is 45, and then I have one more, so it's 46. So if you're looking at that, right, so I have 46 milliliters, so not quite 50. So while it said 50 on here, right, it wasn't quite 50, it was 43. But you can see now it's cylindrical in shape, right, it's shaped like the graduated cylinder. Now if I take that and I have a larger graduated cylinder here, right, and I'm going to pour this in here, okay, get every drop I can out of that. Right, now you're looking at it in this beaker, or in this, sorry, graduated cylinder, right, and you can see it's about the same. It's harder to see these smaller lines here on this one, but you basically can see that it's about the same. So when I move the fluid from one container to the other, right, the amount of space it takes up, or its volume, does not change at all. And so when you look at this, I want to make sure that you understand how that works. So if I need to find the volume of one of these, right, it makes it very difficult, right, to measure length times width times height, because you have to figure it out. Now, you can do the volume of a sphere, right, and you can get your measurements that way and calculate the volume of a sphere, but there's a much easier way to do this. And it is, notice I have a string hooked to this, and so I'm going to take this ball and I'm going to stick it inside, because now notice, right, when it goes up, or when I put it in, the line goes up. And it says, I'm going to tip it back for a second. And it says 55. So my original amount, let me jump this off. My original amount is 46, right? And this one says 55. So if you take 55 and you subtract 46, you get 9. So according to what we just did there, called the displacement method, in other words, I'm putting a ball in here and I'm displacing the difference, right? Our volume is 9 milliliters. Now, interestingly enough, 1 milliliter is the same as 1 cubic centimeter. So while one's a linear measurement and the other one is a liquid measurement, it is still the same. So this would be 9 milliliters, or it would be 9 centimeters cubed. And if you ever heard in hospitals or in hospital shows, they talk about cc's, right? That's cubic centimeters. So they actually do measure, even though it's in milliliters and liters, they actually do measure in cubic centimeters as well, cc. So anyway, so let's get into why that works a little bit. And long time ago, Archimedes figured out that when you put an object, I'm going to move this down a little bit. When you put object in, it takes up space. So now I have liquid in here, and it's taking up the space of this container, right? So it's taking up the whole entire space of this container. So now, if you can imagine, right, and if you want to put a hypothesis together, you can, right? You imagine, if I put more water in here, right, it'll take up more space because it has greater amount of volume. And when it does, right, put a little bit more in there, and you can barely see it, but it's dripping down the edge. There you can see a little bit better, right? It drips down the edge. So obviously if I put more liquid in, right, it's going to definitely take up more space and therefore fall out. So what I want to do is I'm going to take my cube, right? I'm going to take my cube and I'm going to stick it in there, but let me do this for a second. I'm going to take this back out. Just for a tiny second. I'm going to dump this one out. beaker back in place. And obviously there's going to be a little bit of experimental error here because I'm not working perfectly. And I'm going to take my cube and I'm going to put it in. So I'm going to put it in until it completely submerges. So it's completely submerged. Right, so now I'm going to slowly take it out. Carefully get all the water off. I'm going to try to take this container out without spilling anymore. Like that. Right, and now I'm going to take the amount of water that was displaced. Let me make sure everything's out of here. Take the amount of water that's displaced. Let me put something behind here. Better, can you see better? Yeah, a little bit better. All right, so now I'm going to pour this fluid that I displaced into my container, or into my graduated cylinder. And it looks like it's approximately 13 milliliters. So 13 milliliters of displacement, and remember our number from before was 15.6. So we take 15.6 minus, let me say that was again, 14 milliliters, and it equals 1.6. So that means my measurement with the graduated cylinder had a little bit of experimental error as well. So, 1.6, we can figure out the experimental error. I'm not going to get into it today, but we can figure out whether or not, or how correct, how far off we were. But if you look at, again, right, the object took up space and therefore, right, displaced a certain amount of water, water in the beaker. So I'm going to take this and I'm going to pour this back in. So up to the edge. And now I can do the same thing if I wanted to with my ball, right? And if I put that in, obviously, wait, I got to put more water in. Hang on, I forgot I had this over here. All right, so now it's pouring over the edge. And so again, you can see, I'm not going to measure this because I already have water in there, but you can see when I put it in, right, the water that comes over the edge. So Archimedes figured this out, and if you remember from the notes, he figured it out by getting into the bathtub when it was too full and the water overfilled. And so that is a basic idea of volume and a little bit about Archimedes' principle. I hope that was helpful, and enjoy your day.